Most people think eye color is just a roll of the genetic dice, a random feature you inherit that determines whether strangers call you striking or ordinary. But here's what nobody tells you. Your eye color is actually a biological time capsule that reveals where your ancestors lived, what they survived, and which evolutionary gambles paid off over tens of thousands of years. Even more fascinating, it influences how you see the world in ways you've probably never noticed. From the amount of light your eyes can handle to how quickly your pupils respond to danger, your eye color isn't decorative. It's functional, and the story it tells goes far deeper than you ever imagined. Over 80% of the global population has brown eyes, but that remaining 20% carries mutations so recent in evolutionary terms that some of them can be traced back to a single person who lived when humans were just beginning to farm. Let's break down what your eye color actually reveals and why it matters more than you think. Brown eyes aren't just the most common. They're the original model, the genetic default that kept humanity alive for hundreds of thousands of years. That deep brown color comes from melanin, the same pigment that protects your skin from sun damage. But in your eyes, melanin does something even more critical. It acts as a biological filter, absorbing up to 95% of ultraviolet radiation before it can penetrate the delicate structures inside your eye. For early humans navigating the African continent under relentless solar exposure, this wasn't a cosmetic advantage. It was the difference between functional vision and degenerative damage. Research from ophthalmology journals confirms that people with brown eyes have statistically lower rates of macular degeneration and certain types of cataracts compared to lighter-eyed individuals. The melanin doesn't just block harmful UV light. It also reduces light scattering inside the eye, which means less glare and sharper contrast vision in bright environments. If you have brown eyes, you've probably noticed you can tolerate bright sunlight better than your blue-eyed friends. That's not psychological, it's physics. Your iris is literally designed to handle intense light without overwhelm. But there's a trade-off most people don't realize. That same melanin that protects you in bright conditions can be a disadvantage in low light. Because melanin absorbs light rather than letting it pass through, brown-eyed people may have slightly reduced light sensitivity in dim environments. This isn't a defect, it's an evolutionary calibration. Your ancestors didn't need to see perfectly in the dark. They needed to survive in full sun without going blind by age 30, and brown eyes delivered exactly that. What's even more interesting is the variation within brown eyes themselves. Not all brown eyes are created equal. Some contain so much melanin they appear almost black, offering maximum UV protection. Others have a lighter, amber-toned brown that sits somewhere between full melanin saturation and the lighter eye colors. This spectrum exists because melanin production is controlled by multiple genes working in concert, and slight variations in those genes create the rich diversity of brown shades we see across populations. Brown eyes also have a cultural dimension that's impossible to ignore. In most of the world, brown eyes are associated with warmth, trustworthiness, and stability. Psychological studies have shown that people unconsciously perceive brown-eyed individuals as more approachable and reliable, possibly because brown eyes are so prevalent they feel familiar and safe. There's no biological basis for these perceptions, but they shape social dynamics nonetheless. Throughout human history, brown eyes have been the standard, the baseline against which all other eye colors are measured. Now let's talk about what happened when that standard got disrupted. Between 6,000 and 10,000 years ago, somewhere near the Black Sea region, a child was born with a genetic mutation that would eventually spread to hundreds of millions of people. This mutation occurred in a gene called OCA2, which regulates melanin production in the iris. The mutation didn't eliminate melanin entirely, it just dialed it down dramatically. The result? Blue eyes. And here's the part that shocks most people. Every single blue-eyed person alive today, whether they're Swedish, Iranian, or Brazilian, descends from that one individual. Genetic research published in Human Genetics Journal traced the specific mutation and confirmed it appeared exactly once in human history. Before this mutation, blue eyes didn't exist. After it, they spread with shocking speed. Within just a few thousand years, blue eyes went from a single anomaly to dominating parts of Northern Europe, reaching frequencies as high as 89% in some Scandinavian and Baltic populations. But why? What made this random mutation spread so explosively? Scientists have debated this for decades, and the answers reveal something profound about human evolution. One theory focuses on environmental adaptation. In the far north, sunlight is weaker and winters are long and dark. The same melanin that protects brown-eyed people in Africa becomes less necessary and potentially disadvantageous when you need to capture every available photon of light. Blue eyes contain minimal melanin, which means more light reaches the retina. In low light conditions, this could provide a real visual advantage, helping northern populations see better during months of twilight and darkness. Some researchers argue this gave blue-eyed individuals better hunting success, improved navigation, and fewer accidents in dim conditions. But there's a competing theory that's equally compelling: sexual selection. Blue eyes were so rare and visually striking when they first appeared that they became intensely attractive. Humans are visual creatures, and novelty in appearance often drives mate choice. If blue-eyed individuals were perceived as more desirable, they would have more offspring, and the trait would spread rapidly even without any survival advantage. Recent evidence supports this. DNA analysis of ancient European remains shows that some early Europeans had blue eyes paired with dark skin, proving that light eyes evolved independently before skin lightening. This means blue eyes weren't just a side effect of adapting to northern climates. They were selected for directly, possibly because they were beautiful, unusual, and therefore valuable in the genetic marketplace of mate selection. But blue eyes come with vulnerabilities that most people never consider. That lack of melanin that makes them so striking also leaves them exposed. Without melanin's protective filter, blue eyes are significantly more sensitive to bright light and UV damage. Studies show that people with blue eyes have higher rates of light sensitivity, increased glare discomfort, and greater risk for certain eye conditions over their lifetime. This is why you'll notice blue-eyed people squinting more in bright sunlight or reaching for sunglasses faster than their brown-eyed counterparts. It's not preference, it's necessity. The irises simply can't filter light as effectively, so the eyes compensate by narrowing the aperture and triggering discomfort signals. There's also something most people find unsettling when they learn it. Blue eyes aren't actually blue. There's no blue pigment in the iris whatsoever. The color you see is an optical illusion created by light scattering. When light enters an eye with very little melanin, shorter wavelengths in the blue spectrum scatter and reflect back out, while longer wavelengths like red and yellow pass through. It's the exact same phenomenon that makes the sky appear blue even though air has no color. This is why blue eyes can look dramatically different depending on lighting conditions, appearing bright and icy in direct sunlight, soft and gray in overcast conditions, or even slightly greenish under certain artificial lights. The color isn't fixed. It's a dynamic interaction between light and structure. This variability gives blue eyes an almost chameleon quality that other eye colors don't possess. Then there are gray eyes, which take the blue eye phenomenon to an extreme. Gray eyes are exceptionally rare, appearing in less than 3% of the global population, with the highest concentrations in Northern and Eastern Europe. They contain even less melanin than blue eyes, resulting in a different kind of light scattering that disperses across multiple wavelengths instead of concentrating in the blue range. This creates that distinctive steel or silver appearance that can shift from pale gray to dark slate depending on environmental factors. Functionally, gray eyes represent the absolute limit of melanin reduction. They offer virtually no UV protection and maximum light sensitivity, which makes them poorly suited for bright environments, but potentially advantageous in consistently low light conditions. Some researchers theorize that gray eyes may have evolved as an extreme adaptation in populations living in the cloudiest, darkest regions of Northern Europe, where sunlight was scarce and diffuse year-round. The lack of melanin would allow maximum light capture in those perpetually dim conditions. Culturally, gray eyes have always occupied an interesting psychological space. Because they're so rare and their color is so neutral, they're often perceived as enigmatic or emotionally unreadable. There's less color variation to track, which may subconsciously make it harder for others to read emotional states. Throughout literature and folklore, gray eyes have been associated with wisdom, detachment, and mysticism, possibly because their rarity made them seem otherworldly. Now let's talk about the rarest common eye color on the planet, green eyes. Only about 2% of people worldwide have true green eyes, and the genetic recipe required to produce them is extraordinarily specific. Green eyes need a precise balance of low to moderate melanin levels, combined with a yellowish pigment called lipochrome. Too much melanin and they'd be brown. Too little and they'd be blue. Green exists in that narrow sweet spot where light scatters through minimal melanin, while lipochrome adds a yellow filter, creating that distinctive green hue when the two colors optically combine. But here's what makes green eyes genuinely unique. They're chemically unstable. Green eyes are more sensitive to environmental factors than any other eye color, often appearing to change dramatically based on lighting, clothing colors, surrounding environment, and even emotional state. This isn't imagination. The lipochrome pigment interacts differently with varying wavelengths of light, and the low melanin content means external light has a significant impact on how the eye appears. In bright sunlight, green eyes can look golden or hazel. In shadow, they may appear almost gray-green. Under fluorescent lighting, they might take on a blue-green tint. This dynamic quality has made green eyes a focal point of fascination and superstition across cultures. In medieval Europe, green eyes were sometimes linked to witchcraft and supernatural ability, possibly because their color-changing nature seemed uncanny and inexplicable. In Celtic and Slavic folklore, green eyes were thought to indicate special connection to nature or hidden knowledge. Even today, green eyes carry associations with mystery, creativity, and intensity, though these are cultural constructs rather than biological realities. Genetically, green eyes are most common in people of Celtic, Germanic, and Slavic ancestry, with the highest concentrations found in Ireland, Scotland, Iceland, and parts of Eastern Europe. In some Irish populations, up to 86% of people carry the genetic variants for green eyes, though not all express the phenotype. The genes involved are complex and interactive, requiring contributions from at least 16 different genetic loci to produce the right combination. This complexity explains why green eyes can skip generations or appear unexpectedly in families without recent green-eyed ancestors. From an evolutionary perspective, green eyes may have offered adaptive flexibility in temperate forest environments, where lighting conditions varied dramatically between dense canopy shade and bright clearings. The moderate melanin provides some UV protection while still allowing reasonable light sensitivity, striking a balance between the extremes of brown and blue. This versatility might have been advantageous in the mixed landscapes of prehistoric Europe, where humans moved between different light environments throughout the day. Then we have hazel eyes, which confuse almost everyone who tries to categorize them. Hazel eyes are genetic shapeshifters, genuinely changing appearance based on lighting, surroundings, and even what colors you're wearing. This isn't an optical illusion or trick of perception. It's a physical phenomenon driven by intermediate melanin levels and variable lipochrome distribution that interact differently with changing light conditions. One moment hazel eyes appear predominantly green, the next they look golden brown, then suddenly they have gray-blue tones. This color-shifting ability is the defining characteristic of hazel eyes and sets them apart from every other eye color. While green eyes may shift slightly, hazel eyes can transform dramatically, sometimes appearing to be completely different colors in the span of an hour. This happens because hazel eyes contain patches of varying melanin concentration and lipochrome across different regions of the iris. Some areas are heavier in melanin, appearing brown. Others have less melanin with more lipochrome, appearing green or gold. Still, other regions have minimal pigment, creating blue-gray zones. When light hits these different zones at different angles, different colors dominate your perception, creating that trademark shifting quality. From an evolutionary standpoint, hazel eyes represent the ultimate hedge bet. Sitting squarely in the middle of the melanin spectrum, they offer moderate UV protection without sacrificing too much light sensitivity. This makes them remarkably adaptable to mixed environments where lighting conditions change frequently throughout the day or across seasons. If your ancestors lived in temperate regions with variable weather patterns, forests that alternated between dense shade and sun-dappled clearings, or climates with dramatic seasonal shifts, hazel eyes would have provided genuine functional advantages. They're not optimized for any single extreme, but they perform reasonably well across a broad range of conditions. About 5% of the global population has hazel eyes, with higher concentrations in people of European, Middle Eastern, and Central Asian ancestry. Genetically, hazel represents a blend rather than a single distinct trait. People with hazel eyes often come from families with diverse eye color backgrounds, and the hazel phenotype emerges when genetic contributions from different ancestral lines combine in specific ways. What makes hazel particularly fascinating is the sheer unpredictability. Two people with hazel eyes can have completely different color distributions in their irises. One person might have predominantly green irises with brown sunburst patterns around the pupil. Another might have brown irises with green outer rings. A third might have a mottled mixture of gold, green, and brown, with no clear dominant color. This variation creates an almost fingerprint-like uniqueness that makes hazel eyes impossible to standardize or predict. Culturally, hazel eyes have been associated with warmth, approachability, and emotional expressiveness, possibly because their color-changing nature makes them seem responsive and dynamic. Throughout history, artists and poets have described hazel eyes as windows into complex personalities, though this says more about human pattern-seeking behavior than actual biological correlation. Now let's address amber eyes, which are so rare and distinctive they're often confused with light brown or hazel, but they're neither. Amber eyes appear in less than 5% of people and contain a unique combination of high lipochrome concentration with minimal melanin, creating a solid, uniform golden or copper color that remains stable across all lighting conditions. Unlike hazel eyes that shift, amber eyes maintain that rich, honeyed appearance, whether you're in bright sunlight or dim indoor lighting. This stability comes from the lipochrome pigment dominating the iris structure so completely that light doesn't scatter variably the way it does in hazel or green eyes. The result is striking and somewhat unusual in human populations. Amber eyes look almost luminous, with a warmth and intensity that draws attention. Interestingly, this exact coloration is common in predatory animals like wolves, eagles, hawks, and owls, which may explain why amber eyes can appear instinctively commanding or alert to other humans. Some evolutionary psychologists theorize that humans subconsciously associate this eye color with focus, confidence, and predatory awareness, traits that might have offered subtle social advantages in ancestral environments where projecting strength mattered for status and mate selection. Unlike eye colors that evolved primarily for environmental light adaptation, amber eyes may have spread more through sexual selection and social dynamics than functional vision advantages. Their striking appearance made them memorable and attractive, which accelerated their transmission through generations even without clear survival benefits. Genetically, amber eyes appear most frequently in individuals of Southern European, Middle Eastern, Asian, and South American descent, though they can emerge in any population given the right genetic combinations controlling melanin and lipochrome production. The genes involved are different from those producing hazel eyes, which is why amber maintains color stability while hazel shifts constantly. This genetic distinctiveness also explains why amber eyes often run in families as a recognizable trait rather than appearing randomly like some eye colors do. At the opposite end of the spectrum, we have what people call black eyes, though true black eyes don't actually exist in humans. What appears black is an extreme concentration of dark brown melanin so dense that the iris looks completely uniform and opaque. This maximum melanin saturation makes black eyes the most effective at absorbing light and blocking UV radiation. In equatorial regions where solar exposure is constant and intense year-round, this level of protection provides measurable health advantages. Research confirms that people with very dark eyes have significantly lower rates of UV-related eye damage, including certain types of cataracts and macular degeneration that accumulate over decades of sun exposure. The melanin acts as a permanent biological sunscreen that never wears off and never needs reapplication. Beyond UV protection, black eyes filter harsh light more effectively than any other eye color, which reduces glare and eye strain in bright conditions. This makes vision more stable and comfortable in high-light environments where lighter-eyed people would be squinting constantly and experiencing visual fatigue. The dense melanin also absorbs light so completely that the iris appears flat and uniform with no visible texture or color variation. This optical absorption has an interesting social dimension. Because black eyes absorb so much light, it's harder to see pupil dilation changes that naturally occur with emotional arousal, fear, or attraction. In lighter eyes, pupil changes are obvious and provide subtle cues about emotional state. In very dark eyes, those changes are nearly invisible, which some interpret as emotional inscrutability or mystery. Culturally, black eyes have been associated with depth, intensity, and strength across many societies, possibly because their uniform darkness creates an impression of focus and self-containment. Then there's heterochromia, the condition where someone has two different colored eyes or noticeable color variations within a single iris. This affects less than 1% of the population, making it extremely rare. Heterochromia occurs when melanin distributes unevenly during eye development, usually due to benign genetic variations, mosaicism where different cells carry different genetic instructions, or localized developmental changes in the womb. In most cases, heterochromia is completely harmless and simply reflects the fascinating variability possible in human genetics. Complete heterochromia means each eye is a distinctly different color, one brown and one blue, for instance. Partial heterochromia means one iris contains two different colors, like blue with a brown wedge. Central heterochromia means the inner ring around the pupil is a different color than the outer iris, which is actually more common than most people realize. Historically, heterochromia has been viewed with fascination and sometimes superstition. Various cultures have interpreted it as a sign of supernatural connection, divine favor, or dual nature, probably because it breaks the bilateral symmetry humans unconsciously expect in faces. In reality, it's simply a beautiful example of developmental biology producing unexpected outcomes. Your eye color is a living record of your ancestral journey. From the melanin-rich brown eyes that protected the first humans crossing African savannas, to the blue-eyed mutation that spread through Ice Age Europe, from the rare green eyes that emerged in Celtic forests to the stable amber eyes that commanded attention through sheer uniqueness, each color represents a chapter in the story of human adaptation and survival. But it's more than history. Your eye color influences how you experience light, how your eyes respond to different environments, and even how others unconsciously perceive you. So the next time you look in the mirror, remember, you're not just seeing a color. You're seeing the accumulated genetic wisdom of thousands of generations, the environmental pressures your ancestors faced, and the remarkable biological diversity that makes humanity so endlessly fascinating. Your eyes aren't just windows to your soul, they're windows to your past.